Hi students, already we discussed that reactivity series of metal. There is high reactive elements, middle reactive and least reactive elements. Now the extracting process of metals, that is in low reactivity, that is activity series. What are the low reactivity elements mean? Like gold, silver, copper, mercury. So these are the least reactive element. See, these metals are non-reactive. Actually, these metals are non-reactive. The oxides of these metals can be reduced by heating. So these metals are non-reactive. The oxide of these metals can be reduced by heating. For example, that is mercury extractions from cinnabar. Cinnabar means what? That is HGS. So this is cinnabar. The name is cinnabar, mercury ore. See, for example, mercury sulfide react with that oxygen on heating. On heating, you will be getting the metal oxide, that is mercury oxide. Then the sulfur dioxide goes out. Then this mercury oxide, the metal oxide, further on heating to get mercury and oxygen is 2 and 2. So this is the extraction process of mercury from cinnabar. Similarly, copper sulfide. Similarly, Cu2 plus sulfide can be reduced. That can be obtained. That is the same process, similar process. Cu2s, same like this, oxygen 3O2 on heating. You will be getting 2 Cu2O, that is copper oxide, then sulfur dioxide. Then again the copper oxide react with copper sulfide. You will be getting the pure copper, that is 6 moles of copper and this is CO. CuO and the sulfur oxide. So this is the process, extraction of the low grade metal, that is low reactive in this series. So this is mercury and copper. The remaining metals are there. Similarly, the sulfide containing silver, then gold. Gold naturally occurs in free state only. So only the remaining metal is what? Silver. Okay. Then the extraction metals in the middle in this series. Next is extracting metals middle in the reactivity series. See, here the first point is these metals usually present the sulfide or carbonates both. These metals usually present as sulfide or carbonate ores, that is CO3 carbonate, that is carbonates. Then it is easier to obtain metal from their oxide. It is easier to obtain metal from their oxide. So for example, that is extraction from metal sulfide ore means that is roasting. carbonate ores means we are going to do that is calcination process. First, we will see the extraction from metal sulfide ore. Extraction from metal sulfide ore. That is roasting process. Its name is roasting process. The roasting process means the sulfide ores are converted into metal oxide by heating, that is the strongly heating, it converts to metal oxide, then with the presence of oxygen. Okay, see the sulfide ores are converted into metal oxide by heating strongly in the presence of oxygen. So now the reaction example equation is 2 moles of zinc sulfide, that is sulfide of zinc, in the presence of oxygen on heating. This is strongly heated, you will get 2 moles of zinc oxide. The sulfide ores converts to oxide, then sulfur dioxide. That further the zinc oxide can be using we can use the reducing agent, we can convert the pure zinc. This is the roasting process. Then extraction method from carbonate ore. The next is the extraction from metal carbonates ore. For example, this calcination process. The first one is roasting. This is for sulfide ore. This is for metal carbonate ore. This name is calcination. The calcinations mean the carbonate ores are changed into oxide. The carbonated ores are changed into metal oxide. Then metal oxide in strongly heating. Here presence of oxygen, here absence of oxygen or limited supply of oxygen. Absence of oxygen or limited supply of oxygen. So example reaction is zinc carbonate. Example zinc carbonate ZnCO3 on strongly heating, it converts to zinc oxide and carbon dioxide. So further that you can using the reducing agent, you can remove the oxygen from this. So this is the extractions metals middle activity in this series. The middle activity series, what are the middle activity series metal means? It is zinc, iron and lead. So these are middle reactivity series in the metal activity series. Okay, the next is reducing, that is reduction metal oxide to metal. This is the metal oxide, we can reduce from metal oxide to metal. Reduction of metal oxide to metal. Yes, already we discussed that calcination roasting process. What you will get, that is zinc oxide. That is reduction process means, that is reduction means the removal of oxygen from a compound, we have to use reducing agent. That is carbon monoxide, hydrogen. So these are called reducing agent. Why we are using the reducing agent? See, in order to, without reducing agent, the reaction will be very expensive, that is costlier. So in order to reduce the cost of the reaction, we have to use the reducing agent. That means the high temperature. See, the zinc oxide on heating high temperature, it will convert zinc and oxygen. But this reaction is very expensive. So because of very high temperature means we have to spend more money in this reaction. So in order to reduce our cost of this reaction, so we can use carbon monoxide, hydrogen. These are called a reducing agent. So reduction means what? Removal of oxygen. That is addition of hydrogen. There are so many examples are there. There is removal of oxygen. So here we can use the zinc oxide react with carbon. This is called a reducing agent. So this reducing agent, using of this, you will be getting zinc and carbon monoxide. So using of reducing agent, the reaction that you will be getting pure zinc. That means the cost wise the reaction is very low in compare with these two. So that we are using the reducing agent, or you can use zinc oxide carbon monoxide. You will be getting zinc and carbon dioxide. Both are reducing agent. Which one is the best reducing agent? That deals with the Ellingham diagram that you are going to learn in higher studies. Okay, not in this level. So here you can use the zinc oxide. In the presence of carbon, you will be getting zinc and carbon monoxide. Okay, then extracting metal from the top, that is activity series in the high reactive elements. The top reactivity series metals like potassium, sodium, calcium, magnesium, aluminum. So these cannot be reduced with the help of the metal oxide from metal to metal oxide, means that is metal oxide to metal. That means you can use the reducing agent that is only in middle reactivity series. In top reactivity series, that is high reactive elements, you cannot use that the reducing agent, because you cannot get a proper result, that is a proper metal. That's why we are using the electrolytic process. So that's mean these metals are extracted by electrolytic reduction. Electrolytic reduction from their molten state. Then these metals are highly reactive, so that they are not reduced with reducing agent. Usually they are not reduced with reducing agent. It's reducing agent like carbon monoxide, hydrogen. So that is the extraction of example, extraction of NaCl, extraction process. See, that is in electrolytic process mean using of the molten NaCl. Example, I am using the extraction of, that is here in electrolytic process you have one, that is electrode. One is the cathode, another one is anode. So this, the one end is, this is cathode. They have a negatively charged, that is cathode, and the positive charge is anode. So this is the solution like NaCl. This is a sodium chloride solution. Here the extraction of the sodium chloride from sodium metal means, that is sodium chloride to sodium, means metal deposit on the cathode. Here the cathode. So what is the ion here? Negative ion. So that here the NaCl is Na plus and Cl minus. So the metal deposited on the cathode, because of the cathode having a negatively charged and anode having a, the metal atom having a positively charged. So that here attracted here. So that the Na is deposited here. That means Na plus deposited in the cathode, and the chlorine, that is the chlorine is liberated at anode, because anode having a positive charge in Cl minus having negative charge, so that this chlorine Cl minus deposited, that is not deposited, liberated on the anode. So this is the cell reaction, it's called a cell reaction. There is one NaCl. Na gives, that is Na plus and one electron, and the minus Cl minus one electron to reduce Cl2, so that this will become 2, so this will become 2 Na plus. So using of this reaction, that is 2 NaCl gives 2 NaCl. Okay, so this is the reaction. Okay, so the cell reaction. So here what is the conclusion is, the metal deposited at cathode, that is Na plus deposited at cathode, and Cl minus liberated at anode. This is the electrolytic process of the metal, that is we cannot use, they are not reduced with reducing agent, so that we are using the electrolytic process, that is electric current, using of electric current. Okay students.